Hey guys, this video we're going to look at the fundamental theorem of algebra. In our last notes we actually talked about it a little bit, how it's, we're going to be finding all the roots. The highest exponent in the polynomial, which is the degree of the polynomial, tells you how many roots the equation has. So if it's an x to the fifth, a fifth degree, it will have 5 roots. Some of them could be real, some could be imaginary. Some could be rational, some could be irrational, any combination of those, but that's how many it'll have. And today we're only looking at rational and irrational, and we'll get into some more imaginary. We'll do some more focus on imaginary roots in the next lesson. But first, the difference between this lesson and the last one is now we don't know any roots to get started with, and it's a 4th degree. Last lesson yesterday there was only a 3rd degree. We were told one and then we solved out the rest. This one we don't know any, so we have to first figure out possibilities. So any root, any rational root, is going to be in the form that we're going to call P over Q. P is the constant, the back number. Q is the front number, the leading coefficient. So we look at all of the factors of P, the constant, the back number. So factors of 4 are 1, 2, and 4. And actually it could be positive or negative for any of those, because you can get a negative 4 by doing positive times negative, or a negative times a positive. It doesn't really matter. So it'll always be plus or minus. And now we're going to do Q, which is the leading coefficient, which is 9. So factors of 9 are 1, 3, and 9, and then same idea, we can look at them as being plus or minus. Typically I wouldn't do them at this step. How I will write these out is factors of the back, P, will be 1, 2, and 4. Factors of the front are 1, 3, and 9. And now you take all those possibilities, all those combinations. So we could do 1 over 1, which is 1. 2 over 1, which is 2. 4 over 1, 4. And now we can do them all over 3. 1 over 3, 2 over 3, and 4 over 3. And then 1 over 9, 2 over 9. If any of these were to reduce, you would just reduce them. 4 over 9. So these are all the possibilities for rational roots. And then, like I mentioned before, just don't forget the plus or minus. I usually only write it at this step. So when you list them all out, this is all you're doing. You're listing them just like that. That's all this question said. It just said find the possible rational roots. So if that's all it says is find the possible rational roots, you're just writing out all those fractions, and that's it. Our next step would be to test those and see which ones work, which ones are actual roots. So then we would just do synthetic division and get see which ones work. So we're going to do the same idea here. Since we've got fractions, we're going to clear out the fractions. It's still the same equation if you clear out fractions. So we're going to multiply by the common denominator, which is 6. So we multiply by 6. 6 over 2 is 3. 6 times 5 is 30. 6 times 4 is 24, divided by 3 is 8. 6 times 8, 48. And then 6 times 1 is 6, divided by 3 is 2. So we cleared out the fractions by multiplying by 6. Now we will do the P over Q thing. So we take factors of the back, 2, so those factors are 1 and 2, over factors of the front, which is 3. 1 and 3 are the only factors. And now we take those possibilities and list them out. 1 over 1, 2 over 1, 1 over 3, and 2 over 3. You put the plus or minus on each one, and those are your possibilities. So the next step would be to see which ones actually work, which ones are actual zeros or roots. So what we would do is just do synthetic division and test those out. So we'll do that in our next example, just not this one. All right, so now it says find the possible rational roots, then solve it. So that means we'd have to do then both steps. So possible rational roots would be factors of p, which is 3, over factors of the leading coefficient, which is 1, factors of 3, 1 and 3, factors of 1 are just 1. So there's not that many options for this one. This is a lot easier, fewer things to test. It could only be 1 or 3, and then just remember it's plus or minus each of those. So these are our only possibilities. And then we're going to test and see which ones work. We're going to test them with synthetic division. If we get a remainder of 0 from synthetic division, then it works, and it's a 0 or a root. So we'll start with positive 1. Synthetic division, we make sure we're not missing any powers here. So when we do this synthetic division, remember it's add and multiply. So add, multiply, add, multiply, add, multiply, add, multiply, add. So obviously this one does not work. We got a remainder of 32. And maybe you kind of realize something here. Since we're only adding and multiplying, we're not going to get a 0 unless there's a negative in the mix. There has to be a negative number somewhere. And none of our coefficients were negative. So positive 1 can't work because there's no way to get a 0 there because we can't subtract anything. We're only adding. Same thing then with, we're going to save some time. We're not going to do positive 3 either, because we're only going to get larger numbers. The numbers just get bigger and bigger. When we did 1, we ended up with 32. I imagine we're going to end up with something in the hundreds if we plug in or do synthetic division with 3 there. So let's skip over trying positive 3, and let's move on to the negatives. Let's try negative 1. Let's scoot this over, provide a little bit more space. Whoa. All right, so negative 1. And again, our coefficients are 1, 6, 12, 10, and 3. So now when we add, we get 1, but now we're multiplying by negatives, so that's going to create negatives, which makes it possible for these numbers to get smaller, hopefully down to 0. Negative 7 gets 3, and then negative 3, perfect. We got a 0. So that means that negative 1 worked as a root. It is a root. Negative 1 is one of our solutions. Second thing that I wanted to throw out there is, well, when we do this, we're going to be dividing into what's left here. So we're only going to continue doing synthetic division after something works. And then what I was going to say before was just because negative 1 worked once, it doesn't mean you're done with it. It could work again. And then additionally, if you look at these are all still positive numbers. So it would be pointless to try positive 1 or positive 3 for synthetic division. So that also cuts down your options there a little bit. So let's try negative 1 again. Let's see if it works. So that'd be 1, negative 1, 4, negative 4. Looks like it's going to work. 3, negative 3, and we got a 0. So it worked again. Again, just because it worked twice doesn't mean it won't work a third time. You could try it again. Or you can also, once you're down to just these 3 numbers here, remember that would turn into a polynomial. And what I prefer to do at this point is put the x's back and then just factor it. Factoring is easier, in my opinion, than doing synthetic division again, because factoring is going to just almost instantly get your last 2 answers here. So what multiplies b3 adds to b4? 3 and 1, so that's x plus 3, x plus 1, you would get x equals negative 3, x equals negative 1. So that tells us negative 1 would have worked again, and negative 3 would have worked if we tried synthetic division with that. We would have got a remainder of 0. So we have 4 solutions. We got x equals negative 3. Remember, we put them least to greatest. Negative 3 and negative 1. And then rather than writing negative 1 3 times, we'll say negative 1 with a multiplicity of 3. You can abbreviate. That's totally fine. And then it was just those possibilities that we came up with from the beginning. And they were negative for the reasons that we said, where it had to be negative because there was no sign changes. There were no negatives in the equation. There's actually a little trick that says that the number of sign changes, so since it starts positive, it never changes signs because it's positive, 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 positive. It never changed signs. The number of sign changes tells you the number of positive roots. It's a little bit of a shortcut there. So this one, when we look at it, it changes signs 1 time. So since we've got those negatives in there, a positive root could work. Probably just one of them, though. Let's write out our possibilities. P over Q, so that would be factors of 4 over factors of 2. Factors of 4 are 1, 2, 4. Factors of 2 are 1 and 2. And then we're going to take all those possibilities. So we're going to take 1 over 1, 2 over 1, 4 over 1, and then everything over 2. 1 over 2, 2 over 2, which is 1. And we already wrote 1, so we don't need that. And then 4 over 2, which is 2. We already wrote down the number 2, so we don't need that either. So these are our possibilities, 1, 2, 4, and 1/2. And then they are all plus or minus. So this one, we said it has that sign change, so it could have a positive root. It only has the 1 sign change, so only 1 positive is going to work. We really don't know what it's going to be, so we just got to start trying. Let's start with positive 1. Let's see what it is. So writing down the coefficients, nothing is missing, so that'll be 2, negative 1, negative 9, and negative 4. Add and multiply. That'll be positive 1, negative 8. All right, so that's not it. So 1 doesn't work. How about negative 1? That's not a 0, so negative 1 doesn't work either. So now let's try 2. multiply, we got 4, add, multiply, add, multiply, add. That didn't work either. So now let's try negative 2. Oops. So we add, and then multiply, add, and multiply, add, and multiply. Still not working. What's our next number? 4. 4 and negative 4. So let's try those. Add, multiply, we got 8. Add, we got 7. Multiply, we get 28. Add, we get 19. 19 times 4, is that 76? 72. You could have just stopped because you knew it wasn't going to be 0. So 4 didn't work. What about negative 4? So we add and then multiply. And then 27. 27 times 4 is 108. Again, you don't have to actually calculate this out because you know it's not 0. You can just stop, but I've got it. I'll write it for completion. That didn't work. So I guess, hopefully, maybe it's the plus or minus 1/2 then. So let's try those two. So synthetic division with a fraction. We haven't actually done that in an example yet, but it works the same way. It just gets a little bit weird when you're multiplying. Hopefully not, but it could. All right, so our coefficients. Really hoping this works the first time because I don't want to have to do it twice, but that's okay. All right, so we start with 2 times 1/2 is 1. Oh, good, we get a 0. Times 1/2 is 0. That's easy. Negative 9 times 1/2 is not 4. It's almost 4, but it would have been negative 4.5 anyway. And, all right, let's try negative 1/2. Hopefully. Two, negative 1, negative 9, negative 4. I have a good feeling about this one. Maybe because it's the last one and hopefully one of these works. So, 2 times negative 1/2 is negative 1. So that's negative 2 times negative 1/2 is positive 1. That's negative 8 times negative, it's going to be positive. 8 times 1/2 is 4. We got it, finally. So that one worked out. We got a 0, so negative 1/2 does work. And then again, we're left with just 3 numbers here. So now this can be solved, maybe even by factoring. You don't need to do the rest of... now, none of these other ones that we tried already would work. They didn't work the first time. They won't work after you find a root. It doesn't matter what order you do them. So all of those are eliminated. So the only number that could work again for synthetic division would be the negative 1/2 or anything else we didn't try, but we tried everything. So Negative 1/2 is the only possibility that could work again. But let's take a look at this and see if this is factorable, because that's way easier than this guessing and checking synthetic division that we're doing. So factoring, we can first factor out a 2 and change this to be x squared minus x minus 8. And then we go to factor it, multiply to be 8 and add to be 1. That's why this was so hard to figure out, is because this remaining part is not factorable. Nothing multiplies to be negative. That's supposed to be a 4, though. Nothing multiplies to be a negative 4 and adds to be 1. 4 is only 2 times 2 or 1 times 4, and there's no way to get 1 out of those two numbers. So it's not factorable, which means to get our remaining roots, which is the direction, find all the roots or zeros, we have to do a quadratic formula just like we did yesterday in our last notes. So negative b plus or minus the square root of b squared, 1 squared is 1, minus 4ac. So negative 4 times 1 is negative 4, times negative 4 is plus 16, over 2a. 2 times 1 is 2. So that simplifies 1 plus or minus the square root of 17. There is no square root of 17. That does not simplify, over 2. And then our other root that we had was negative 1/2. So we can list them with braces. Remember, quadratic formula gets you 2 answers because it's plus or minus, and then there's our third. And that's it. We found all the roots because we found 3, and this was x to the third. On this previous example, we found 4 because we had multiplicity of 3 and then 1 more, so that's 4 roots. We found 4 roots because it was x to the 4th. That's the fundamental theorem that we were talked about on the very first slide. All right, one last thing. Your calculator, Casios actually have a really easy way of doing this. It's a great way to check your work. Make sure you did everything correct. So let's go to equation here in the Casio. And then these are polynomials, so F2 for polynomial. Enter the degree, degree 4. Now we have to select it up here, F3 for degree 4. And then you just type in the coefficients. 1, 6, 12, 10, and 3. And they were all positive. Then it's as simple as just pressing solve. And then it says negative 1 times 3, because that's the multiplicity of 3, and then negative 3. Negative 1 with the multiplicity of 3, and negative 3. So your calculator answers this super easy. Even this next example here, if we type it in, let's type it in first. So this is a degree 3. And then you type in the coefficients. 2, negative 1, negative 9, negative 4. And then solve. You see these decimals, negative or 2.5615. That would be the square root answer we had, and negative 1.5615. That would be the other square root answer, and then there's negative 0.5 right there in the middle. That's our negative 1/2. There's our negative 1/2, and then the other two are obviously square root, or match up with our square root answers. You can, it's a little bit difficult to do this, but you can go to your calculator, the main screen, and then type this stuff in if you wanted to. 1 plus the square root of 17 divided by 2. This particular calculator gives it this way unless we hit fraction to decimal. So let's press that right here. And there's that 2.5615, which we saw. And then the other one, if we type it in like a fraction this time, we'll do 1 minus the square root of 17 over 2. And again, it gives us the square root unless we hit fraction to decimal, and then we can compare it. And those were the same numbers that we saw on the polynomial thing. It's just a quick check, make sure we don't mess up with quadratic formula or something like that. So that's it. Go ahead and submit. Complete your homework found in the Files tab, and then get that submitted. Post any questions, of course, and I will see you next time.